For your VSEPR structures, please make sure that you always start with Lewis structures. If you start and try to figure these out by just using the number of atoms, you may cause problems in finding your VSEPR structure because it not only relates to the number of atoms that are attached to the central atom, it also relates to the number of lone pairs. So the first way that I'm going to divide everything is according to atoms. So if the central atom on your Lewis structure is bonded to two atoms, and only two atoms, and there are no lone pairs, it will be linear in its VSEPR shape. It can also have two atoms coming off, for example, water. But if in this situation, you should also notice that it has two lone pairs. So when the central atom has two atoms coming off, and it also has two lone pairs, it will be bent in structure. The last way that it can have two atoms coming off of the central atom is if it just has one lone pair. In this case, sulfur is behaving very poorly because it only has 6 valence electrons. This is how this compound forms. However, you don't have to remember this rule for sulfur. Next is if you have 3 atoms coming off of the central atom. Ammonia is NH3. If you look, I have 1, 2, 3 hydrogens coming off nitrogen. Nitrogen is the central atom. Nitrogen also has a lone pair of electrons. In a situation where an atom has 3 atoms coming off of it and 1 lone pair, it will take the shape of trigonal planar. In the case of boron trihydride, boron has 3 hydrogens coming off. Remember that boron does not fit our octet rule. It is happy with just 6 valence electrons. Boron and beryllium are the only ones you have to remember that for. In this case, it is trigonal planar if it only has 3 atoms coming off of it. Trigonal, 3, tri, 3 atoms. Planar meaning it will sit flat in its true 3D dimensional shape. The last situation is if you have 4 atoms coming off of it. We don't need to know any more than 4, although there are more that exist. This would be something like methane. 4 atoms coming off, none of which, has 4 atoms coming off with no lone pairs. That is tetrahedral. Tetra is the root word, the prefix for 4. 4 atoms. The other way that you can learn these is by the number of lone pair electrons on the central atom. So for example, if we look at carbon, 0 lone pairs of electrons on the central atom, it will be linear with 2 atoms coming off. In carbon, there are no lone pairs of electrons, 4 atoms coming off. It is tetrahedral. The last one is boron trihydride, no lone pairs coming off. It is trigonal planar. Next, we have 1 pair of lone electrons. If you see a pair of lone electrons, it may either be bent or trigonal pyramidal. It just depends on the number of atoms coming off. The major difference here, bent, 1 pair of lone electrons, 2 atoms coming off. Trigonal pyramidal, 3 atoms coming off with 1 lone pair of electrons. The last is if you have 2 lone pairs of electrons. No matter what, if you have 2 lone pairs of electrons coming off, it will be bent. For tomorrow, there is just a little bit of information that will help you. And so LPE, make sure you know it stands for lone pair of electrons, and bonds each count towards the steric number. If you have 2 sterics, meaning either 2 atoms coming off, or an atom and a lone pair of electrons, or if you have any situation where you have either a lone pair of electrons or a bond, and there are 2 of them, they're going to have 180-degree bond angles. When we start talking about hybridization, that will be an sp hybridization. If you see that it has 3 sterics coming off, meaning either 3 atoms or a combination of 2 atoms and 1 lone pair of electrons, they would have a 120-degree bond. That does get smaller if you're involving a lone pair of electrons because they take up more space due to repulsion. They would have a hybridization of sp2. We'll talk about that more tomorrow. Last is if you have 4 sterics, meaning 4 atoms coming off, or 3 atoms coming off with 1 lone pair of electrons, or 2 atoms coming off with 2 lone pairs of electrons. Those will have approximately 109.5 degrees in their bond angle and a hybridization of sp3. I hope this helps you. If not, I'll be here tomorrow morning, and I will also be going over this a little bit more in class today and tomorrow. Bye.